Good day, everyone. My name is Rhouela Francisco, and today we will be talking about phonology. What is phonology? Phonology is a subfield of linguistics that studies the structure and systematic patterning of sounds in human language. It is also a description of the sounds of a particular language and the rules governing the distribution of those sounds. It is a part of the general theory of human language that is concerned with the universal properties of natural language sound systems. Let's go to the internal structure of speech sounds, which is the distinctive feature theory. In 20th century, it was discovered that consonants and vowels are in turn composed of more basic units which are called the distinctive features. One phonetic feature is voicing. It plays a crucial role in the statement of phonological regularities such as plural rule. It is minimally distinctive that it serves to distinguish phonemes such as Z and S in minimal pairs such as zip and sip. So again, distinctive features refer to the phonetic features of human language that play a crucial role in the statement of phonological rules and or distinguish phonemes from one another. The point and manner of articulation represent a prima facie acknowledgement that speech sounds can be characterized by the phonetic features that make up these sounds. It helps in picking out classes of sounds that is necessary for an insightful characterization of plural forms. Now we have here the stop consonants T and D that could be articulated in the following ways. First is dental. The tongue tip makes contact with the teeth. Second, alveolar. The tongue tip makes contact with the alveolar ridge. The third is palatalized, articulated farther back on the hard palate, typically resulting in the creation of affricates such as sh and t. Or coronal. The tongue blades rises to approach or contact the teeth, the alveolar ridge, or the prepalatal region of the roof of the mouth. In dental, where the tongue tip makes contact with the teeth, for example, in Japanese and certain continental European languages, T and D are dental stops. In alveolar, for example, in English, T and D are alveolar stops. In palatalized and in English, the words don't and you is pronounced as doncha, doncha. While in Japanese, the phoneme T has the positional variant of sh when followed by the high vowel I or the J, a palatational process also found in Brazilian Portuguese, which like the Spanish has dental stops. Now these examples illustrate that despite minor differences in the articulation of T that exist across languages, these stops undergo very similar palatational process. To this end, a good deal of research in phonology has been aimed at defining a set of phonetic features that will allow us to abstract away from English and other languages in such a way that we can refer to consonants and vowels in general fashion with cross-linguistic validity. Now moving on to the feature coronal. Now coronal stops are all articulations in which the tongue bladed raises to approach of contact the teeth, the alveolar ridge, or the prepalatal region of the roof of the mouth. It is a more general feature than the feature alveolar. As we examine the range of languages, the need to devise a feature system that has universal validity becomes even clearer. Moving on to the SPE-based system. Now later on, in tables 4.1 and 4.2, there are listed consonants and vowels of English as they are classified in a distinctive feature system based on the one proposed by Morris Hall and Noam Chomsky, the sound pattern of English. So as you can see here, this is the table 4.1 where we show the distinctive feature composition of English consonants. In SPE-based system, the features are viewed as binary, which means having one of two values, either a plus value, which indicate the presence of a feature, and a minus value, which indicates the absences of the feature. Distinctive features, by convention, are enclosed in square brackets. Now, phonemes in the SPE system are regarded as bundles of features, that is, as groups of binary features. Many developments in distinctive feature theory and phonology in general that have taken place since the publication of SPE are omitted here. In particular, the distinctive features have been shown to be hierarchically organized, a fact that the presentation does not take into account. Okay, here in table 4.2 are shown the distinctive feature composition of English vowels. Now, these are the universal features. Now we go to the first one, which is syllabic. This is assigned to phonemes that can function as the head or peak of a syllable. The vowels in English are syllabic. Next is consonantal. This is formed in the vocal tract with an obstruction that is at least as narrow as that of a fricative. Moving on to sonorant. This is produced with a vocal tract activity in which spontaneous voicing is possible. In other words, the vocal tract is not constricted to the extent that airflow across the glottis is inhibited. Voiced. Phonemes are voiced when the articulation is accompanied by a periodic vibration of vocal cords. All phonemes in the word bead are plus voiced. Continuant. Minus continuant are sounds that are made with a complete blockage of the oral activity. Meanwhile, plus continuants are sounds that are made without such blockage. Nasal. Phonemes are plus nasal when the velum is lowered during speech, thus permitting the airflow and sound energy to activate resonances in the nasal activity. Strident. Plus strident sounds are characterized by high-frequency turbulent noise that accompanies the production of sound fricatives and affricates. Distributed. This refers to the relative length of contact that the tongue makes along, not across, the roof of the mouth. Affricate or delayed release. Recall that affricates are produced by articulatory gestures during which the airflow is temporarily stopped, but stoppage is secondarily released into a fricative. Labial. A labial articulation involves a bringing together or closing of the lips. Round. A round articulation involves an extension and pursing of the lips. Carnal. In articulating a plus carnal phoneme, the blade of the tongue is raised toward or touches the teeth, the alveolar ridge, or an area along the back of the alveolar ridge. Anterior. Anterior sounds are made with a primary constriction in front of the alveopalatal position. Labial, interdental, and alveolar articulations are plus anterior, high. In articulating a plus high phoneme, the body of the language is raised toward or touches the roof of the mouth. Moving on to back. Plus back phonemes are made with the tongue body slightly retracted from the rest position, while minus back phonemes, also called front, are made with the tongue body in a relatively forward position. And lastly, low. Phonemes with this feature are made with the tongue body lowered and the root retracted. Next is phonemes as groups of distinctive feature. So here is a table 4.3, that shows us the stop and affricate consonants in 4 unrelated and geographically separated languages. Languages draw upon different features to make up their phonemes. However, there is a surprising amount of convergence in the sound systems of human language. To get a wider perspective, consider the consonants listed in Table 4.3, drawn from 4 languages from their stops, at the same time general points along the vocal tract. The role of distinctive features in the expression of phonological rules. Recalling the plural rule from Chapter 3, Hypothesis 3, or the use of phonetic features, tells us that letter A, the plural morpheme, takes the voiced form z if the last sound in the noun to which it attaches is an alveolar fricative, an alveopalatal fricative, or an alveopalatal affricate. Otherwise, letter B, the plural morpheme takes the voiced form z if the last sound in the noun is voiced, and letter C, the plural morpheme takes the voiceless form s if the last sound in the noun is voiceless. However, there is no evidence for the assumption that there are 3 different plural forms given as a list. In fact, there is an alternative, namely that plural morpheme has one shape and that there are conditions on the pronunciation that determine the realization of the different plural shapes. Pinker and Prince argued that the basic shape of the plural morpheme is Z and that all variations are due to phonological rules of English. Epenthesis. If the plural morpheme is Z, then an I must be present between the plural morpheme and the final phoneme of the noun. Epenthetic vowels also occur elsewhere in English. Some dialects insert an epenthetic between consonants and I. With the previous remarks, we are now able to formulate the final version of the plural rule. The plural morpheme is Z and is subject to the following conditions. If the noun ends in a plus trident, a plus coronal consonant, an epenthetic is inserted between the plural ending and the noun. Otherwise, if the noun ends in a minus voiced consonant, the feature minus voiced is spread to the plural morpheme. Note that we no longer have a unified set of statements that specify all the forms of the plural. This Z shape is not the result of the rule at all, but rather the basic form that is unchanged by the rule. Natural class. A natural class is a set of phonemes uniquely defined by a small number of distinctive features such that the set plays a significant role in expressing the phonological regularities found in human language. While the unnatural class is a collection of phonemes that cannot be uniquely specified by a small number of distinctive features. In Amharic, a language spoken in Ethiopia, the vowel I is a variant of the vowel. Forms showing these alternations are given in the following slide. So here we can see the Amharic form and then the English gloss. Here are the evidences that support the distinctive feature analysis of phonemes. Number 1, their role in describing the contrastive or distinctive properties of phonemes in the world's languages. Number 2, their roles in insightfully describing the phonological regularities or the rules found in the language. And lastly, our imaginary language would be constructed so that every sound is maximally distinct from every other sound. In fact, however, languages are organized differently. The external organization of speech sounds. There are two important organizational units, and these are the syllable and the foot. Moving on to the syllable. It is a structural unit that hierarchically combines the consonants and vowels in a word according to organizing principles that can vary across languages. Here in figure 4.1, we can see that letter A is the typical syllable structure and letter B is the syllable grouping of the word napkin. Across the world's languages, the common types of syllable has the structure of CVC, that is, a single consonant followed by a single vowel, followed by in turn optionally by a single consonant. As figure 4.1a and 4.1b together show, vowels usually form the center or core of a syllable called nucleus. Consonants usually form the beginning, the onset, and the end, the coda of the syllable. The properties of a syllable is somewhat more complex than one might think. In the first place, it is not only vowels that can serve as the nucleus of a syllable. Word internal syllable division is another issue that must be dealt with. In a sequence such as VCV, where V is any vowel and C is any consonant, is the medial C the coda of the first syllable or the onset of the second syllable? The aspiration rule. The aspiration rule provides a test for determining which syllable an intervocalic consonant is associated with. P is a minus continuant and a minus voiced phoneme. If the intervocalic P in the sequence APA is the onset of the second syllable, it will be aspirated. If it is the coda of the first syllable, it will not be aspirated. It is informally stated that in aspiration rule, phonemes with features minus continuant and minus voiced are aspirated in syllable initial position. Maximal onset principle. In here, the sequence of consonants that combine to form an onset with a vowel on the right are those that correspond to the maximal sequence that is available at the beginning of the words. Maximal onset principle simply states that within a word, any series of consonants between vowels is divided so that the syllable on the right ends up with a maximal allowable number that satisfies the conditions of English syllable onsets. In our characterization of the phonology of language as consisting of sounds and rules, we see that there are rules that specify the allowable sequences of phonemes and that the unit in which these combinations are specified is the syllable. The pattern of prominence or stress. The syllable in English words are not all pronounced with the same degree of prominence. They vary in emphasis, length, and as well as we will see later, pitch. In order to understand the role of stress and its patterns of occurrence in English words, we need to consider an additional structural unit that organizes English syllables: the foot. The foot. The term foot is common in the study of poetry, where it plays an important role in scansion. Metrical feet also play a fundamental role in English phonology, and just as syllables, the foot provides an external organizational frameworks for syllables. Metrical feet is the units of prominence and timing. The first element of foot, the first syllable, carries the strongest beat of the foot, and the following syllables within the foot are relatively less prominent. The beat of a foot is in fact the property that determines the stress patterns of English words. Now, there are three types of foot. The first type is unary foot, which has one branch. The second type is the binary foot, which has two branches. And the third type is the ternary foot, which has three branches. Now, in this figure 4.2, we can see the different types of foot. Linking vowels to foot structure. For purposes of exposition, we will make some simplifying assumptions concerning the underlying form of English words, in particular with respect to phonemes. It is sufficient for our purposes to assume that the lexical form of words consists of vowels, the tense and the lax, and the reduced vowels. In figure 4.3, we show the 3 feet of figure 4.2 are with 3 words associated. We include the internal structure of the syllable as part of the representation in figure 4.3, although we omit it in subsequent representations. In the foot structure of English words, a single reduced vowel is in the nucleus of the right-hand syllable of a binary foot, and 2 reduced vowels are in the nuclei of the 2 rightmost syllables of a ternary foot. Tense vowels and English foot structure. Although leftmost syllables of a foot always contains a full vowel and never a reduced vowel, it is not the case that a full vowel cannot occur in the right branch of a binary foot and in the 2 right branches of a ternary foot. There are 2 conditions on tense vowels. The first condition is the vowel sequence condition. The second condition is the word final vowel condition. Vowel sequence condition. When 2 vowels are adjacent in an English word, the first vowel must be tensed or long. For example, hiatus and radio. Word final vowel condition. Only reduced, tensed, and low short vowels can appear in word final position. The short non-low vowels cannot appear in word final position. For example, the words sofa and baby. Here in figure 4.5, we show words in which a tense vowel occurs in a non-leftmost member of a metrical foot. Figure 4.5 displays the words motto and radio. In each of these words, the rightmost syllables of a binary or ternary foot not only contain a full vowel, they contain tense vowel that satisfy one of the 2 conditions. Here we can see in figure 4.6 the word veto showing its assignment to two metrical feet. English flap rule. Flapping is a process that occurs when T or D appears between two vowels, the first of which is stressed more than the second. This formation is not quite correct, although it is consistent with the words water, attitude, and beating. In Figure 4.7, metrical structure of the word attitude, showing that the first T is between vowels in a foot and the second T is not. Figure 4.8 shows us that the ternary foot assigned to editor that permits both alveolar stops to be flapped. Looking at the word attitude in the figure 4.7, we see that it consists of 2 feet. The first T is between vowels that are members of the same foot and thus satisfies the terms of the flap rule, whereas the second T is between vowels that are members of different feet and thus does not satisfy the terms of the flap rule. In figure 4.9, we show that the lack of flapping on the second alveolar stop in editor as a consequence of the last syllable being assigned to its own metrical foot. In figure 4.10, we show the lack of flapping in the word veto and the appearance of flapping in veto as a consequence of their different metrical structures. You can see how the difference in metrical structure illustrated in the figure 4.10 leads to the difference in pronunciation between these two words. The in veto being mildly aspirated and the in veto being lapped. This difference cannot only be heard, it can be seen in the spectrograms that is shown in the two words in figure 4.11. One property of English metrical structure might appear to be problematic: the presence of word initial syllables containing unstressed vowels in some words. So here is the figure 4.12. Rather than introduce more types of feet into the description of English, we propose that English permits a single unfooted, unstressed syllable only at the beginning of a word. Thus, the initial syllables in figure 4.12 are not shown to be associated with a foot. So we have 3 cases in the role of metrical feet in English phonology. The first is the variability of length in vowels. The second is why vowel pairs such as these are used in phonemic transcriptions. The third is changes in foot structure as the source of changes in pronunciation. Figure 4.13 shows us the changes in foot structure in the two words leading to a change in pronunciation. As adjustments are made in the foot structure of certain words, reduced vowels are appearing and the pronunciation of these words is changing. Defooting is one of the most common adjustments, and its effects are seen in the current pronunciation of the words gymnast and assassinate in figure 4.13. In figure 4.14, the changes in foot structure that led to the homophony of the words effect and affect. Because of the changes in its foot structure, English has more reduced vowels now than it did earlier in its history. These reduced vowels are spoken language often lead to spelling difficulties in written language. For example, the difficulty people have in the spelling of the words effect and affect can be traced to the defooting of the initial vowel, as shown in figure 4.14. Moving on to the special topic, the word level tone contour of English. In addition to differing in loudness because of their position in foot structure, the syllables of an English word differ in pitch, a perception based on the frequency of the vibrations of the vocal cords. Figure 4.15 shows us different tone patterns of English words, H being high tone and L being low tone. There are conditions for linking tones. The first condition is the English tone pattern, which is high, low, high. The second condition is the English tone assignment. The high tone links with the most strongly stressed syllable in the word, and the low tones spread to any available syllables to the right or left. There is only one additional detail to consider, namely the variable behavior of the tone contour when the high tone is assigned to a syllable on the periphery of the word. When main stress falls on the first syllable, there is no evidence of low tone to its left. In contrast, when main stress falls on the last syllable, there is evidence of a low tone to its right, and that falling tone occurs. Here in figure 4.16, we show words exhibiting the spreading of the English tone contour. The parentheses indicate that the first low tone is optional, and if there is no syllable to the left, the stressed syllable with a high tone, this tone will not be realized. In contrast, the low tone on the right must be realized on any syllables present. If no such syllables are present, it will be conjoined with a high tone, forming a high-low falling tone contour like the one in the word underneath in figure 4.16. Here in figure 4.7, we show different syllable structures lead to the different tone contours on the word seer falling HL and seer HL sequence. In chapter 3, we noted that English words seer and seer are pronounced differently. For one thing, seer is monosyllabic and seer is bisyllabic. We are now able to point out a consequence of the English tone assignment principles. The word seer has a falling contour HL over its one syllable, whereas the word seer has an HL pattern over its two syllables. These differences are displayed in the figure 4.17. The principles of tone assignment and spreading described previously are not just found in English. Similar principles are extremely common in the languages of Africa and are also found in Japanese. Now we have reached the conclusion. At the beginning of this chapter, we posed the following questions. What is the proper description of the various sounds that are found generally in human language? What is the proper general framework for describing the patterns of human language? We are now in a position to provide partial answers for these questions. The speech sounds of human language at either phonemic or at the phonetic level of representation are best viewed as complexes of phonetic features, out of which the speech sounds are composed. Phonological regularities are best expressed in terms of the phonetic features that make up phonemes. The statements typically refer to small classes of features that identify the natural classes of phonemes. And that concludes my report. Once again, this is Rhouela Francisco, and thank you for listening.